So here in section 1.2, we're going to continue our talk about segments and go deeper into it, but also talk about congruence. So to start, we are going to begin with vocabulary. A rule that is accepted without proof is called a postulate or axiom. You're very rarely going to use the word axiom, though. You're going to not see that used very often in our textbook or in class. Typically, we're going to call these postulates. So what a postulate is, it's a rule that is accepted without proof. So it's just something that has to be true in order for us to be living, breathing human beings on this planet, for the world to work. So let's take a look at our first postulate, number 1. Ruler postulate. The points on a line can be matched 1 to 1 with the real numbers. The real number that corresponds to a point is the coordinate of the point. So basically here, the ruler postulate is kind of describing the number line. The distance between points A and B, written as AB, so we'll talk about that in a second, is the absolute value of the difference, meaning subtraction, of the coordinates of A and B. Distance is always positive, so that's why they're using the absolute value, because the answer in an absolute value problem is always positive. So what they're saying is, if you want to find the distance between points A and B, just to take the coordinates of B, subtract it from the coordinates of A, and you'll figure out what the distance is, as long as you change it to a positive if it happens to be a negative. So for instance, if point B is at 10, and point A is at -3. If I take 10 minus -3, that means I have 13 units in between. Again, we're going to use absolute value just in case we happen to get a negative number. We would have 13 units between points A and B if A was at -3 and B was at 10. So again, these are just things you just know are true because you're a living, breathing human being living on this planet. So again, coming back to this whole length of a segment, which was referred to in that first postulate, it says when referring to the length of segment AB, again, notice how I read that. I read it as segment AB because I had a segment line up here, and I knew it was a segment because I did not have arrows on that symbol. So if I want to refer to the length of a segment, I write it as just AB. So if you saw these two things, JM, and then JM with a segment symbol on top of it. If I was looking at this first, I know this is talking about the length of the segment, and this is referring to the segment itself. So once again, if there is not a segment symbol on top, they're referring to the length of that segment. But if there is a segment symbol on top, they are referring to the segment itself, and it's going to be read as such. You would read this as the segment JM. You would read this as the length of segment JM. Let's move on. When 3 points are collinear, meaning they're all on the same line, you can say that one point is between the other two. So let's take a look at these pictures. If you notice here, we have a line with points A, B, and C on it. So we have 3 collinear points. So since we have 3 collinear points, we can say that point B is between A and C. However, when you look at this diagram, D, E, and F are not all sitting on the same line. It may appear like E is between them because it's, D is over here and F is over here, but in order for us to state that E is between them, E would have to be on the line with D and F. So point E is not between D and F in this figure. So just to reiterate things that we would talk about in class, geometry is very specific. And very detail oriented. So once again, very subtle differences between if we're talking about a segment length or the segment themselves, then we're going to have the difference between having the symbol and not having the symbol. Or in order to use the word between, we actually have to have them collinear first before you can say a point is between two others. So again, very specific and very detail oriented. So let's take a look at postulate number 2. Keep in mind that postulates are things that just have to be true. So here's the segment addition postulate. It states if B is between A and C. Notice they're using that word between. In the last slide, we learned that in order to use the word between, that A, B, and C would have to be collinear. So again, the fact that they're using the word between, we can assume that points A, B, and C all lie on the same line, that they are collinear. So if B is between A and C, then the length of AB plus the length of BC is equal to the length of AC. Notice that I'm saying the length of each of these segments since the symbol for segments is not used. So the length of AB plus the length of BC would equal the length of AC. So if you look at our diagram here, we have AC, and then we have segment AB and segment BC. So what they're saying is if segment AB was equal to 3 units and segment BC was equal to 2 units, then AC would equal 5. So we're just adding them together to get the total length. We can also use the flip side of this. If we know that the length of AB plus the length of BC is equal to the length of AC, then you can automatically assume that B is between A and C and that B is collinear with A and C. Once again, by using the word between, we can assume that all 3 points are collinear. So let's take a look at example number 1. We have this diagram over here, and our first part says find, and I'm going to read this as the length of XZ. So if you notice here, XZ is here to here, and we're given the length of XY and YZ. Due to the segment addition postulate, we know that the length of XY plus the length of YZ would equal the length of XZ, since these two smaller segments make up this bigger segment XZ. So if XY is equal to 23 units and YZ is equal to 50 units, that means that XZ is equal to 73 units. So again, make sure our answer is clear. XZ would equal 73. So that would be our answer to part A. For part B, it states if the length of WY is 30, can you use the segment addition postulate to find the distance between W and Z? It's always helpful to label your diagrams with the information that you're given. So we are told here that the length between W and Y is 30 units. And we're now asked, if we know that, can we use the segment addition postulate to find the distance between W and Z? So if W is here and Z is here, they're asking that, can we just add 30 to 50 to figure out that WZ is 80? But the key here is the Y here is not between the W and the Z in order for us to assume that WY and YZ would equal the length between W and Z, because Y is non-collinear with the W and the Z. So therefore, we cannot use the segment addition postulate to find the distance between W and Z. Once again, our answer would be we cannot use the segment addition postulate to find the distance between W and Z because this point Y is not between W and Z. In order for us to use the segment addition postulate, the 3 points would have had to have been collinear, and they are non-collinear points. So here's example number 2. It asks us to find, and again, notice how I'm going to read this, find the length of segment CD. So they're asking for this length right here. We are given that CE is equal to 42, and we're given that DE is equal to 17. According to the segment addition postulate, we would know that CD, the smaller segment, plus DE, the other smaller segment, would equal the total segment CE. So by substituting this in, we know that CE is 42, we know that DE is 17, and we don't know what CD is. So it's just like we're going to solve an equation, which ends up with us just subtracting 17 from 42. So 42 minus 17 would give me an answer of X equals 25. So therefore, CD would equal 25. Back to more terminology. Line segments that have the same length are called congruent segments. The symbol for congruent is, it's like an equal sign with a squiggle on top of it. You're going to see that a lot. So let's look at this next diagram. It says that we have segment AB and we have segment CD. In order to mark that they are the same length or that they're congruent, you put a little tick mark on it. So we see this red tick mark to indicate that AB and CD are congruent. So look at this terminology. If I want to say that their lengths are equal, then I'm going to use AB and CD without the segment symbol on top and use an equal sign. So I would read this as the length of AB is equal to the length of CD. If I want to state that the segments are congruent, then I have to use the segment symbols on top. So this would be read as segment AB is congruent to segment CD. So if I'm talking about their lengths, I use an equal sign and I don't use the symbols. If I'm talking about congruence, I use the symbol for segments and a congruence symbol. Very subtle difference, and they mean basically the same thing, but you just need to be aware of this difference. So let's take a look at example number 3. It says graph the points x, -2, -5, y, -2, 3, w, -4, 3, and z, 4, 3 in a coordinate plane. Are segments x, y, and wz congruent? So let's first get to work at graphing these points. Keep in mind that when graphing an ordered pair, the first number in ordered pair is the x, the second number is the y. So your first number is going to tell you whether you're going to go left or right. Your second number is going to tell whether you're going to go up or down. So for x, which is at -2, -5, I'm going to go to the left 2 and down 5. So you can see here we have point x down here. For y, we have -2, 3. So that means I'm going to go to the left 2 like before, but this time up 3. And you can see here, left 2, up 3, got us that point right there at y. For w, I have -4, 3, so I'm going to go to the left 4 and up 3. And for z, I'm going to go to the right 4 and up 3. So now that I have all 4 points graphed, they're asking are segments x, y, and wz congruent? So let's actually draw these segments in. Luckily, since these are straight lines, like completely vertical or completely horizontal, I can just count units to figure out how long each segment is. So again, we just need to count how many units are between each endpoint of each segment. So xy would be 8 units long, and again, all I did was count the number of units there are between the x and the y. And then moving on to how long WZ is, I just once again need to count how many units there are between the W and the Z. And I would get that WZ is 8 units long. So since the segments have the same length, I can state that segment XY is congruent to segment WZ. Once again, I was asked if they're congruent, so I used the congruent symbol, which means I had to refer to them as segments, not the lengths of the segments. And now let's take a look at our last example, number 4. It states point S is between R and T on segment RT. So by the fact, again, that they're using the word between, we can assume that points S, R, and T are collinear. So let's draw a picture. Always draw a picture so you can visualize what's happening. So again, we're starting with segment RT, and then S is going to be between those 2 points. So just like that. Again, we have segment RT, and S is somewhere between it. We don't know it's exactly halfway or anything. We just know it's somewhere in between the R and the T. It says, use the given information below to write an equation in terms of X. Solve the equation, then find the length of RS and the length of ST. So let's refer to the segment addition postulate. According to the segment addition postulate, we know that the 2 smaller segments, RS and ST, when added together would equal the bigger segment RT. So again, we would have RS plus ST equals RT. In the information that we're given, we are told that the length of RS is 2x minus 8, the length of ST is 3x minus 10, and the total length of the segment RT is 17. So let's just substitute this stuff in there. So if we have RS is 2x minus 8, we would have 2x minus 8 plus, and again we know that ST is equal to 3x minus 10. That's in our given information up here. So we'll replace the ST here with 3x minus 10. So again we have 2x minus 8 plus 3x minus 10. And we know that's equal to RT, which we are told in our given information is equal to 17. So 2x minus 8 plus 3x minus 10 equals 17. So now that we have this equation, we're going to solve for x. So combine like terms, 2x plus 3x is 5x. Negative 8 minus 10 would be negative 18. I would add the 18 over, so I'd have 5x equals 35, and then dividing both sides by 5, I'd end up with x equals 7. So it said write an equation and solve for x in the instructions. It says write an equation in terms of x, solve the equation. So we know that x equals 7. And then it says find RS and ST. Well, now that we know that x is 7, I can substitute that back in up here and find out that RS is equal to 2 times 7 minus 8. So 2 times 7 is 14. 14 minus 8 is 6. So RS equals 6. And for ST, I'm going to substitute the 7 in, so I have 3 times 7 minus 10. 3 times 7 is 21. Minus 10 would be 11. And notice that if I add the 6 to the 11, I get the 17 total that I was given originally. Another way to do it is once you figured out what RS is, knowing that if RS is 6 and the total length between R and T is 17, you could have taken 17 minus 6 to get the 11 for the ST. So either way would work and you get the same answer no matter what. That's it for this section. Make sure you jot down anything you did understand that we can cover in class before we move on, and we'll see you then.